Forces is possibly the biggest topic in GCSE physics at the minute. It's an incredibly fundamental topic. Okay, it's very important across the entire board of physics. So I think we will spend quite a few videos on this, getting down some of the more key concepts behind all of physics. What is force then at its most basic level? So at the most basic level, forces are things that can change objects' speed. They can change an object's direction, or they can change an object's shape. Okay, so later in the topic you will actually learn that these two things can be combined to form something called velocity. Okay, so in other words, forces can change an object's velocity and it can change an object's shape. Yeah. Now, what else about forces do we need to know? Well, we need to know that it is a vector quantity. What do I mean by a vector quantity? What is a vector quantity? Well, let me draw a force here. So if I've got a block here and I exert a force on it, yeah. Now, forces are measured in a unit called newtons. Okay, so let's say I exert 20 Newton, a Newton force on it. That's newtons. So imagine I exert a 20 Newton force on this block. Okay, it's going to want to change speed. It's going to want to speed up that way, and it's going to speed up. Okay, so this is going to change the object's speed. What do you notice about this? So I've got the size of the force. Yeah, I've got the magnitude of the force on the block. Yeah, the magnitude or its size is 20 newtons, and it's acting in this direction. Yeah, it's acting to the right. So that's what forces are then. Forces are something forces are a vector quantity. Forces have a magnitude indicated by this number and a direction indicated by this arrow. Yeah. So then let's summarize. So vectors are things that have a magnitude and a direction. Okay, so what other things are vector quantities? Well, we know force is a vector quantity. Yeah, we've also seen, okay, in the forces basics bit, that we can combine speed and direction to form velocity. Therefore, velocity is also a vector quantity. Okay, it's the speed of an object in a particular direction. Displacement, we'll learn a bit more about that later on in the topic. Acceleration, that's a vector quantity. Okay, you can have positive acceleration. It means something's speeding up. Or you can have negative acceleration. That means it's slowing down. Okay, and we've got momentum as well, which we will come across and look in quite some detail later on in the series. Okay, so what does it mean then? Some quantities don't have a direction associated with it. Some quantities just have a magnitude. Okay, so those quantities are what we call scalar quantities. Okay, scalar quantities are things that just have a magnitude. So speed, for example, speed is just a magnitude. We've got direction, that is just so distance, that is just a magnitude. Okay, there's no direction associated with it. Mass, you couldn't associate a direction with mass, could you? Yeah, so that is a scalar quantity. Temperature, again, you can't associate a direction to temperature because that would just be weird. Yeah, it's just a scalar quantity. It's just got a magnitude. Likewise, time is just a magnitude. Okay, so those are scalar quantities. Scalar quantities have just a magnitude. Vector quantities have a magnitude, but also a direction as well. Okay, remember, magnitude is just another way of saying size. Yeah, right. Back to forces then. We need to know the difference between contact forces and non-contact forces. Most forces you come across require contact between two things. For example, friction. Friction is a force. Friction acts to slow things down. Okay, that's the force between two surfaces in contact with each other. So that's a contact force. Air resistance and water resistance. Sometimes we call both of those drag. Okay, so drag, that's friction between the air and an object, or the water and an object, okay, or any fluid and the object. That's That's contact forces because it's contact between that fluid and the object. Normal contact forces, we will learn more about that when we talk about Newton's third law. Okay, basically the force that stops you from falling through the ground. We've got tension as well, which is like in ropes. If you pull something with a rope, or if you stretch a spring or something like that, that's tension. Okay, so you're putting tension into things. Non-contact forces, forces that don't require contact with things. Gravitational force, sometimes we call that weight. Okay, so weight then, if you were skydiving, yeah, you are not in contact with the earth, yet you are still experiencing the force of gravity. So that's a non-contact force. Magnetic forces, magnets interact with each other even if they're not touching each other. Electrostatic forces, those are forces that you get from, say, if you rub a balloon in your hair, you can stick it to the wall. That force is still going to be felt even if it's not stuck directly to the wall. So those are contact forces, non-contact forces. Right. Start of a big topic then. I will see you in the next video.